When you pour out a glass of fresh, purple-hued grape juice, it's easy to think it's just pressed fruit, but behind that deep purple color lies a careful and scientific process. It all begins in vineyards around the world, where grapes get specifically grown for juice processing, not winemaking. Picture rows of sunlit vineyards stretching across rolling hills with each grape ripening under the warm glow of a late summer. What seems simple on your breakfast table goes through multiple reforms to become the drink many adore. Today at Whole Process, we're going behind the scenes to uncover the mystery behind every delicious sip making up this juice. If you enjoy these videos, don't forget to subscribe and like so that we can continue making more of these. But first, how are these grapes grown? Growers monitor grape development through the summer. Samples are taken periodically to measure their sugar levels. Because of this reason, harvest timings are of key consequence to this entire affair. Grapes get harvested at optimum maturity, typically when soluble solids reach 16 to 20 Brix. This is the balance at which sweetness and acidity yield a full-bodied, fresh juice. Sugar level, acidity, and color are tested on site using handheld refractometers and even titration kits. Though the methods of harvesting tend to diversify depending on the type of vineyards, many modern-day ones focus on juice processing, having fully mechanized grape harvesters to dull the load. They work by attaching themselves at the base of each grapevine and then using large amounts of force to shake the fruit off of these vines into the bins. The positives of this method are numerous. It helps cut down on costs of hiring labor to do the task slowly by hand. In fact, the biggest plus point in the promptness, the grapes can be picked at any time of the day and night and take much less time. However, there are many advantages to manual grape picking too. Manual labor helps lessen the damage to the grapes themselves, preventing them from getting bruised from the rigorous shaking of the mechanical harvesters. Once picked, the grapes must be processed quickly. Natural yeast on grape skins begin fermentation within hours if temperatures exceed 20 degrees Celsius. For this exact reason, the loads are transported almost immediately, typically with a short time span of 2 to 6 hours to nearby facilities. At reception, each truckload is weighed, inspected, and even sampled to check the freshness of each grape. Samples are then tested for soluble solids, pH, and even the presence of mold or decay. Any fruit that shows spoilage gets immediately tossed to prevent the whole batch getting contaminated later on. Once this is done, the grapes get unloaded into large receiving hoppers that funnel the fruit onto conveyor belts for sorting and even cleaning with water. The operators remove leaves, stems, and any damaged grapes. In fact, with the technological advancements in this day and age, many plants employ optical sitters with high-speed cameras and near-infrared sensors that automatically detect color and shape defects. Depending on the facilities, some may even have metal detectors to warn of any metallic debris that may have fallen in the load previously. But that's not all. Many have also started integrating air-jet rejection systems that blow off any unwanted materials from the belts without the use of manual handling. But how do they get rid of those pesky grape stems? The clean grapes actually pass through a destemer, which is essentially a rotating drum, which works to strip the berries from their stems. The stems get discarded because they impart bitter, tannic flavors and increase the solid load in later stages. The journey never seems to end because then the separated berries fall onto another conveyor, heading to the washing units. The reason for these multiple washings is because it's vital for removing the soil and pesticide residues from the grapes. But that's not quite enough to remove any microorganisms, so chlorinated or even ozonated sprays come into play. These are used to effectively destroy bacteria, yeasts, and even molds on the grape surfaces. After washing, the cleaned fruit is inspected visually before entering the crushing section. The crushing stage is the fun part. The goal is to rupture the grape skins and release the juice by separating the liquids and solids. The grapes get fed into roller crushers or even screw crushers that gently break the skins, leaving an output of a mixture of juice, pulp, skins, and seeds. This is called a must. Temperature during the crushing process is controlled around 15 to 20 degrees to limit oxidation and enzyme activity. To hike up the food safety standards, Another notch, stainless steel contact surfaces are used throughout to prevent metallic contamination. There's also another interesting step that takes place right afterward. Many juice manufacturers treat the must with pectinase enzymes derived from food-grade microorganisms. Pectinase breaks down pectin, a natural carbohydrate in grape cell walls that causes haze and traps juice within the pulp. So why is this so great? It increases juice yield by 5 to 10%, shortens pressing time, and improves clarity and filterability in later stages. The amount and contact time are carefully controlled and approved under international food enzyme regulations. After all this enzyme action, the must gets transferred to presses for juice extraction, and two main types of methods are used. The first of these is a membrane press, closed systems that inflate an internal rubber membrane to squeeze the juice gently from the must. This method produces a high-quality, low-solid juice, which is ideal for premium products. The other method is the use of belt presses, continuous systems that move the must between porous belts under increasing pressure, designed for high-volume industrial output. The pressing parameters are adjusted according to the type of grape, with typical cycles lasting 30 to 60 minutes. Juice flows into stainless steel collection tanks, while the remaining solid residue, the press cake, is taken away for secondary uses like animal feed. But did you know that from 1 metric ton of fresh grapes, processors obtain about 650 to 750 liters of raw juice? The remaining pomace, like skins, pulp, and even seeds, is set aside for other uses. For example, in case of the seeds, they may be dried and pressed for grapeseed oil extraction, and the skins and pulp can be used for animal feed and even composting. Immediately after the pressing is done, the raw grape juice produced is actually very cloudy and even has suspended solids along with yeast cells. Because the juice at this stage is considered biologically active, it quickly gets moved over to the next stages, clarification and pasteurization, all to stabilize it before it can get spoiled. The first step to getting that sanitary and delicious juice is clarification. The first clarification is mechanical. The juice passes through rotary screens or decanter centrifuges to remove large particles such as skin fragments and seed pieces. This is done until the major particles are removed, but even though it's gone through its first filtration, that doesn't mean it's clear. In fact, many fine particles are still left in suspension. To remove these, clarifying agents are added. The most common agents used are gelatin and silica sol. What these agents do is essentially bind to proteins, phenolic compounds, and other haze-forming substances. The treated juice is then stored into stainless steel settling tanks for 12 to 24 hours at around 4 degrees Celsius. But why is this colder temperature preferred over warmer ones like room temperature? The clever reasoning behind that is to slow down microbial growth. Over time, a dense sediment settles at the bottom, which simply gets siphoned or decanted out from the top. In larger factories, powerful disc stack centrifuges are ized to speed up this whole process. These can clear the juive in minutes instead of hours. The juice gets filtered again, often through the use of a fine natural powder called diatomaceous earth, or even with a membrane filter with very fine holes. These filters remove any last bits of haze and microorganisms, leaving behind a clear and bright juice. Most commercial grape juice at this stage has almost no visible cloudiness, thanks to these million steps. They all may have seemed unimportant, but the end product proves otherwise. But once the juice is clean, it's not all over. The air still needs to be removed from it. This is done because air is a mixture of a multitude of games including oxygen, and oxygen can cause juice to spoil faster. In order to increase its shelf life, producers use a process called de-aeration. The steps used to do this include firstly using a vacuum system to suck all the air out. This removes over 90% of the oxygen and helps us keep those colors, flavors, and nutrients for longer. Now that the air is removed, there needs to be another gas there to prevent it from entering incognito the packing. This is why factories fill these tanks to the brim with nitrogen gas. Nitrogen is actually completely harmless and doesn't react with any component of the juice. which is why it's often used in food production when it comes to the sealing part. But that's not the only thing that can make the fresh juice spoil. Fresh grape juice can also spoil easily because it contains some leftover bacteria. This is why pasteurization plays one of the most significant roles here. Pasteurization kills harmful microorganisms in a controlled environment. How this happens is that juice is pumped through a heat exchanger system, which is actually a set of metal plates that quickly heat and then cool the liquid. It's heated to a high temperature, but only for 15 to 30 seconds at best. Then it gets immediately cooled down. This ensures that the high temperatures don't completely spoil the drink either. The heating equipment has strict heating controls and temperature sensors to make sure that the juice reaches the correct temperature. Once all this is done, the juice is ready to be bottled and sent on its trip across the country. But before that can happen, samples need to be taken. This is done to make sure that only the best batch is being set out and also to catch any food safety issues in advance. But once everything is cleared up, the juice is finally ready to be packaged. It gets pumped in sterilized bottles, cartons, or cans using aseptic filling machines, which prevent any bacteria or air from entering. Once sealed, they get labeled with the manufacturer's information and date coded, ready to be boxed up in cardboard cartons along with other juice boxes, from where they will be sent over to your local grocery store. So next time you open your fridge to grab a cool and tangy glass of grape juice, you'll remember the effort put into creating just one carton of this drink. What looks like a simple juice box is actually the product of months of technological and manual labor. Every sip of this grape juice represents the months of cultivation and countless checks. Do you like grape juice? Let us know in the comments below. Thank you for watching, and as always, we'll see you in the next one.